Up until now, we have only been dealing with constant velocity, meaning that the velocity is not changing. From here on out, pretty much through the end of the year, any problem you see is going to have acceleration. So we're going to start by defining what acceleration is. We're then going to look at how acceleration comes into play qualitatively, so not yet with numbers, but more just looking at graphs and motion maps. And eventually we will get to the equations dealing with acceleration and problem solving, but that will be in a separate video. So what is acceleration? By definition, acceleration is a change in velocity over a period of time. Since it's a change in velocity, and velocity is a vector, acceleration is also a vector, and it can be positive or negative. The symbol for acceleration is a lowercase a, and the equation for acceleration is its definition. So acceleration equals change in velocity over time. And change in velocity is just delta, so v final minus v initial over time. And I will define each of these letters. So A is acceleration. T is time. Vf is final velocity. And Vi is initial velocity. So if you know the definition of acceleration, you know the equation for acceleration. And when we start dealing more with the equations, we'll see how this equation rearranges to get one of our three main kinematic equations. So how does acceleration change things? For one, our position time graphs, which used to have this shape with a straight line, will no longer be a straight line. Reason why. This straight line indicates a constant slope. Slope of position time graph equals velocity, which means that for a straight line, when we made our velocity time graph, we would end up with a velocity time graph with a horizontal line, because this constant slope meant that we had a constant velocity. Now our position time graphs are going to be curved. So it might make a shape like that. And what this curve indicates is that the velocity is changing at every single point. So this is not a constant slope. Whereas on the previous slide, the straight line was a constant slope. So if it's not a constant slope, that means our velocity time graphs will no longer be horizontal lines. They're going to be diagonals. How do I know what shape the velocity time graph takes? You have to look at the slope at each point on the position time graph to figure out whether they're increasing or decreasing, and then whether they're positive or negative. So let's look at the position time graph very carefully and figure out how I ended up with this velocity time graph. I'm going to draw this big. So you get a graph that looks like this. I think we can agree the shape is a top opening parabola, but it's not something that we're going to linearize because we're not dealing with data. What we are going to do is look and try and figure out what the slope of each tangent line that we can draw on this graph is doing. So what do I mean by that? Let's pick 5 random points. We'll go here, 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 and here. If I were to draw a tangent line at each of these 5 points, I can look at the slopes of those tangent lines to try and figure out at that instant what the velocity is doing. So I'm not going to do any numbers yet. I'm just going to look qualitatively to see what these slopes are doing. This slope right here is a lot shallower than this slope right here. So a shallower slope means a slower velocity. A steeper slope means a faster velocity. From shallow to steep means that this velocity is increasing. So it means it's getting faster and faster. The next thing you have to determine is whether it's increasing in the negative or increasing in the positive. So is it getting faster in the positive direction or is it getting faster in the negative direction? And you answer that question by looking at the sign of the slope. All of these slopes are positive. So velocity is increasing in the positive direction. So how do I know what my velocity time graph would look like based on this position time? Let's draw this nice and big. So time, velocity. If I look at that position time graph, my very first point, if I were to draw a tangent line at that point, would have a slope of 0. So I'm starting at 0. This is positive, this is negative. My velocities start at 0 and they're increasing, so that means they're getting faster and they're getting faster in the positive, which means that my velocity is going to be increasing in the positive, which is how I knew that graph would be a straight line, not horizontal, this time diagonal, in the positive direction. So the the shape of that position time graph would give you a velocity time graph looking like this. I start at 0, that means I'm starting from rest. I am getting faster in the positive. Because the slope of the velocity time graph is no longer 0, I'm going to introduce now a third type of graph, which is the acceleration time graph. If velocity is a change in position over time, and the slope of a position time graph gives you velocity, and acceleration is a change in velocity over time, the slope of a velocity time graph will tell you what the acceleration is. Because all acceleration is a change in velocity, so your change in y over your change in x, delta v over t. So introducing a third type of graph, acceleration time graph, it's going to look a lot like our old velocity time graphs did when velocity was constant. You've still got positive above the x-axis, negative below the x-axis. The slope for that previous graph, the velocity time graph, was constant and positive, which means that my acceleration will be constant and positive. We will not be dealing with non-constant acceleration, so none of our acceleration time graphs will ever be diagonal. They will look like our old velocity time graphs where they were kind of choppy, moving up and down vertically, but they will always have slopes of 0. So your old position time graphs are now what the velocity time graphs look like. Our old velocity time graphs are now what the acceleration time graphs look like. I'm going to show you the 4 main types of position time graphs that we'll see. These are the 4 basic shapes. You can see combinations of these and what they mean in terms of the motion for velocity and acceleration. So the first one I just did. So position time, underneath I'm going to draw the velocity time graph, and underneath that we're going to do acceleration time graph. And I like to draw these one under the other so that you can see how the slope of one leads to the slope of the other. And what's happening here is the object is increasing That was written very badly. Speed in the positive direction. So the graph for position time looks like that. Velocity time looks like this. Acceleration time looks like this. Our next case, so let's draw again the three graphs. Will be decreasing speed in positive direction. So decreasing speed in the positive direction, my slopes have to be positive and they have to be getting shallower. So my position time graph will look like that. And what I mean by slopes, I mean the slopes of the tangent lines, because again, you can't draw a slope for a non-straight line, but you can look at the tangent lines. So if we look at tangent lines along this curve, they start out steep, they get shallower, all of them are positive, which means that for my velocity time graph, I am starting at a positive non-zero velocity, I am ending at 0. So starting in the positive, getting smaller and closer to 0. That should be a straight line. Let's just make that a little bit straighter. And this looks just absolutely terrible, so let's erase it. And try again. So starting in the positive, going towards 0. The slope of this line is going to tell me about my acceleration. It's a straight line if I drew it better. So a straight line indicates a constant slope and it's negative. So that means that my acceleration is constant and negative. Two more cases. So let's draw the position time, velocity time. That should be a t. Acceleration time graph. Now we are going to increase speed in the negative direction. So increasing speed in the negative direction means that on my position time graph, if I were to draw tangent lines, the slopes would have to start out close to 0 and get steeper and steeper, and they would all have to be negative. That graph looks like this. So drawing little tangent lines along this slope shows shallow and getting steeper. All of those slopes are negative, which means my velocity is going to start at 0. It's going to get a larger and larger negative number. So my velocity time graph would look like that. The slope of this line is negative and constant. So my acceleration would be negative and constant. And then our final case that we're going to look at, if I draw my three graphs, excuse the baby, hold on. Our position, velocity, acceleration time graphs will be decreasing speed in the negative direction. So decreasing speed in the negative direction means that for my position time graph, the slopes of any tangent line that I draw have to be negative and getting smaller, so shallower. That graph can only look like this. So if I drew tangent lines at each of these slopes, I start out very steep and negative, slopes at each of these tangent points, and they get shallower, closer to 0, which means that my velocity starts at a high negative and goes towards 0. That graph would look like this. The slope of this line is constant, but it's positive. So my acceleration would be constant and positive. This page has accelerations that might not make sense to you. In other words, you have a negative acceleration, but you're increasing speed, and here you have a positive acceleration, but you're decreasing speed. You need to get the idea out of your head that negative acceleration means slowing down. All it means here is that it's causing the velocity to become more and more negative. So increasing speed in the negative direction will have a negative acceleration. Decreasing speed in the negative direction will have a positive acceleration. I'm going to give you a chart to kind of keep all of this straight in terms of what's positive and what's negative for each of these 4 cases. Okay, so here is our chart. We're going to talk about the 4 different cases. I'll write what those are. And then we're going to look at the sign of the velocity and the sign of the acceleration. And let's get this a little bit straighter. Okay, so our first case will be increasing speed in the positive direction. If I'm moving in the positive direction, my velocity will be positive. If it's getting more and more positive, that means acceleration is adding to the velocity. The only way to get more positive is with a positive acceleration. My next case is decreasing speed in the positive direction. So I'm still moving in the positive direction, which means velocity should be positive, but my speed is decreasing. That means acceleration is taking away from the velocity, so in order to take away from positive, it needs to be negative. These next 2 might be a little counterintuitive, but it's the way it is based on the definition of acceleration. So our third one is increasing speed in the negative direction. You're moving in the negative direction. That means your velocity is negative. You're getting more and more negative. So to add negative to the velocity to make it more negative, your acceleration also has to be negative. So this is a case where negative acceleration does not mean you're slowing down, it actually means you're speeding up. And the fourth case is decreasing speed in the negative direction. Again, this is going to be a little counterintuitive. You're moving in the negative direction, therefore your velocity is negative. However, you're getting less and less negative, which means acceleration is taking away from that negative amount. The only way to get less negative is to have a positive. An easy way to remember this is by looking at the fact that when something is increasing, velocity and acceleration have the same sign. If something is decreasing, velocity and acceleration have opposite signs. So don't get too caught up on the fact that acceleration is negative. It does not necessarily mean slowing down. Again, it just tells you what's happening to the velocity. I will ask this a lot. You will see this a lot. You need to be able to recognize when one is negative, when one is positive, and why. And we'll be dealing with acceleration pretty much the rest of the year, so this is important to know.